Hi, today I will be testing a room. I will check the duration for how much time does it needs to be filled with cold air from coming from the AC using Solidworks Flow Simulation. As you can see, I will now open Solidworks. I have a project already opened. As you can see in the design tree, there's a room. This one is the room, the AC vent, and actually there's a roof, but I make it invisible so that it cannot obstruct. And in my flow simulation, in my flow project, as you can see, I have this AC. This is where this is an inlet velocity. The AC with the wind speed of 8 meter per second. And as you can see, I will first open my project. In my project, this is an internal type. This is an internal, and I exclude this one. See, and in my gravity, I use gravity with the negative y-axis, and the fluids I use only air. I'm testing air here, and in the wall conditions I use adiabatic. And my initial condition, actually I used the temperature for the thermodynamics initially is 30 degrees Celsius. And this project is this is a this is a transient project. As you see, this is time dependent. And in my calculations, control option, I have set the time to 300 seconds. You see, physical, and I have also set a goal for the minimum, maximum, average goals. And in my saving, in the full results, I enabled and periodic saving. You see, it's a 300 seconds analysis. And as you can see, I already have solved and run this project. I have the results, and if you will see, I will load time moment. I will go into the 5 seconds time, and you can see I will open the cut plot. As you can see, as of 5 seconds, the temperature of this room is still hot. As you can see, this is the maximum and the minimum. And also try also to it's better for these levels to be on the maximum, and also in the appearance you can enable this plot minimum and maximum. It's better that way. As you can see, I'll use the probe. It's very hot. As you see, the temperature is 30 degrees at the 5 seconds time. But if we load at the at 200 seconds, you will see it's already getting colder, as you can see. And approximately it took like uh, it took like 300 seconds or 5 minutes to to be in the 15 degrees Celsius. You see, after 5 minutes the room is already cold. So you see, in my project I have this as a boundary condition. This is you see how this is an inlet velocity with a speed with a air velocity speed of 8 meter per second, and the thermodynamics, this is a 15 degrees Celsius, so this is cold. There's a cold air coming out here, and it's filling slowly the room, and it takes 5 minutes for this entire room to be cold, same as the temperature that the AC produces. And as you can see, the size of the room is as you can see the size. As you can see, this is the size of the room. See, sizes of the room, and also the size of the vent for the AC in millimeters. You see, everything is in millimeters. See, this one and this one. And I can also check for the flow trajectory. You can see at the 300 seconds time, It's already cold. It's already cold, you see. It's already cold. The volume, the entire volume of the room is already cold. And we can also close this first. And also this one I will close. And we can also plot. Actually, before I started, I added a goal. I added this global goal. I inserted this one, a global goal, testing the temperature for the fluid because we're testing air, so it will be fluid. We're not testing solids, okay? And then it's already here. And in my goal plots, I will open this. I click edit definition, and I will be testing for the maximum. I am plotting for the maximum, and this is versus time. This is testing over time, as you can see. But first, you need to make the time moment. You have to load for the maximum for the end time, for the max end time, and then and then you open this one, and then you show using this physical time, and then click the maximum because we're testing for the maximum over time. And if you check and you go to summary and go history, as you can see, there's a graph, and it's very clear that over time the temperature is dropping, as you can see. And therefore I conclude that with this kind or with this size of the room, as you see the dimensions of the room, it takes approximately 5 minutes or 300 seconds for this to be filled with 15 degrees Celsius coldness. And if you will see, I will load again this cut plot, and as you can see, the temperature above is much hotter than temperature. With this case, it will be cold because it's in the line with the AC inflow. But if you will go in the side, you see, it's much colder. If you go in the sides, it's much colder in the bottom than in the above. It's cold. It's colder a little in the bottom than in the above. You see. And for now, that's it. We have shown that for this kind of room with this dimension of room, it takes only 5 minutes to make this room cold. And thank you for watching. Bye bye.